Hey guys, welcome to Zealous Tech IT Solution. In this video, I will talk about Python programming techniques. So, and we'll take little examples, very simple example that will help you to understand the basic difference between the types of programming. So, we have functional programming and Python, object-oriented programming, and then we'll cover what is stateful and statelessness of the when we deal with these two programming things, and then it is like uh, we have to decide which programming technique we'll be using. So let's move on to our first topic, that is functional programming. So functional programming is a method, is a paradigm in which we create a function and we pass the arguments to the function and we get the output. That is a very common definition of the function. So every language, though it's the Java, maybe database, PSQL, or for that matter, Perl. Every language have this functional programming paradigm. So why we write the functions? The function is like we need this functionality. We write a code. We write a function. We call that function with some parameters, and we get our results. So that's a very straight definition. Like we don't deal about the architecture. We don't think about the maybe the other aspects like the polymorphism or inheritance. We just need to get our functionality done. So it's like a mathematical function. So we have different types of function, that is pure functions, higher order functions, and the lambda. So let's take the example of pure functions. We have a simple functionality wherein we are creating a list where this list is passed to the function, which is multiply to underscore 2, and then function does the function is multiplying each element in the list by 2. So if you see here, if you closely look at the program, it is not changing any state, it is not changing any variable as such. So if you pass this function, if you pass this list, it is getting passed here. We are creating a local list here to hold a new result. We are just we are looping into the and then the list which we passed and multiplying the each element by 2 and returning the results. So if we see here, no variable, no attribute of the program has been modified. We are creating a new list, but uh, nothing has been modified which is existing. So if we run this, let's run this, and if you see the results, original numbers list is still the same as it was before, and change list was displayed as multiplied by 2. So this function doesn't change anything in the program. So this is called as a pure function. So very simple definition of this. Okay. The next is the higher order function, which is we'll take the example of it. So higher order functions are like the function which are uh, in which we are function passing the one function as a parameter to the other function. It's like a nested kind of function. So let's take a simple example of it. So let's forget about the func tool here. Okay, because it will be before that we'll just see what is the higher order function. Okay, so here we'll just create one function. Let's say depth display, right? It's displaying whatever we have passed. We'll take an input string. Okay, and we'll say now, in this function will, instead of calling the function directly, we'll create, let's say, a var. which is assigned to this, right? And when we call the function, actually we'll say var of var of, right? So when I execute this, okay, so I'll get hi Python, right? So actually in here we are passing this function as a higher order function. So for us, var is a higher order function, and which is passed to the, indirectly it is calling a display function. So this is a very basic difference of the higher order function. So as we saw, we'll be discussing the more practical example of it, which is using the function tools. So here, if you see the recent example, we just created a simple function where we assign the function to the one variable, and then in a variable we are passing the string. So indirectly this is getting passed to the display, and the display function is called, it is printing out the result. So it's like a nested kind of function. Similar to that, we have an example of higher order function. So same way we did the previously we have similar situation here. This is not with the again with the function tools. So here again we are creating the function create adder. Okay, we are assigning it to the variable as a uh, just like a variable, and then when we pass it, when we call the variable, but the variable actually calling the function. So when we run this, we'll see the results, right? This is a 25, right? So here what we did is we have replicated the function. First we called a function with the single parameter, right? Only 15. Y is not like, only x is there, right? Then we call the function with the different parameter 10. So at this point, the function only knows like we have 15 values with us. When we call when we assign it to the one variable, that state is maintained here. And with that state, with the 15 as a state, we're passing 10, which is returning the 25. So this is called as a higher order functions. You got it? So same thing we can implement with the help of function tools. So what is the function tools? Function tools is the module provided by the Python, wherein, as I said before, like we are calling the function, but we are replicating the function. Let's say the function needs a two parameter, right? We are passing the function only one parameter. Function will store that one parameter and store the execution order or execution plan of that function with the single parameter. It doesn't execute, but when we pass the second parameter, it actually executes. So here the same thing we did with the function tools. So this is the module from which we import the partial. Here is a function which is just doing the concatenation of the two string. So first, let's say we are passing this, calling this partial, the one we imported, and then we are calling again a higher order function. Like as we are talking about higher order, a function which is calling within the other function, with the sum. This is the example wherein we are passing the half or the little, I'll say not little, but parameters which are not full. So this is expecting two parameters x, y, but at this point we are passing only the first name. So it doesn't error out saying like I need the two parameters, right? If you create a simple function and pass the only one parameter and function is expecting two, it will fail, right? So but here it will not fail. We are calling this function the first name as a parameter. Information is stored here, right? And then we are calling we're creating the definition. Sorry, here we're not calling anything. So here I just saying like this is the function definition. This is the function parameters that we're saying. Like first we're calling with the first name, and then we're calling with the y is again with the first name. So when we call the function with the actual value, so I forget this point. Let's say this is creating a confusion. So we are passing the function only with a single parameter. It is expecting us two parameters. So we passed only first parameter. When we call the double here now, as the actual definition is stored with this first name as a parameter, it is now with this definition, it is passing the last name also. So now at this point, actual function execution will start. Not at this point, because we are not calling it. We are just assigning a definition of the single parameter. So let's run this and see the result. So if you see, we just like say function point the double, what are the messages, and then we say double last name and first name. So last name is passed here. It is getting concatenated, but the first name was already passed, so the same is getting concatenated. So this is a higher order function, wherein we are calling a one function, replicating its definition for the some parameters. And let's say if you want to pass other parameters at later point of time, we are using that definition, replicated definition, to call the complete function. So this is the higher order function. Then let's talk about the lambda. Lambda is a simple function. Let's say everybody knows like lambda is anonymous functions, wherein we just create anonymous function and pass. So here we don't have any function name. We're just passing the two parameters and returning the sum of it. So and assigning it to variable when we say this complete definition executes. So here, if you see, we are not creating any function with the def keyword, right? We are not creating any function with the def. We are just using a lambda. So when we execute this, let's run this. Yeah. So yeah, the result is 3. So and this is an anonymous function which doesn't have any name. So these are the types of functional programming. These types of function that we create in the functional programming paradigm. Okay. So here, as I talked about, we are not talking about the state, or we are not uh, worried about the state of the any object, or any variable, or any object for that matter. We are just getting what we want to do. We are creating a function and passing the parameters and getting the results. So next is the object-oriented programming paradigm. So Python is object-oriented programming language. It creates the objects, classes, and it supports all the uh, basic pillars like the inheritance, polymorphism, and all the stuff. So we have this simple definition like class is there, then definitions are there. So let's talk about how functional programming looks. So let's take an example here. Oops. So here we have a class where it is separated by a colon. Then we have a def. We are creating the method inside it. Then each method, each of your code, either it's, let's say this is your package, but your module should have the main method which start from where the application execution actually starts. So this is the main function which is actually creating the object of the class. So this is a operation class. This is the object, and we are calling the method, as simple as that. And then we are calling the main method. So this is our entry point. This will call this main method. Main method will create an object of the operation class. Once the object is created, we can call the methods inside it, right? So let's execute this. So we'll see 8 as the answer, as we are just passing and multiplying it by 2. So similar to the OOPS concept, we create a class, we create the method, then in the main, like the way we do in Java, like public static void main, we have the main method here, we create the object of the class, and then we call the methods. So this is a very basic example that we saw to give you the heads up. Okay. So before we go to this topic, we'll just talk about the self as the what is the self. So self is there's a one keyword in the OOPS, wherein not in the OOPS, but specifically talking about the Python, we have the self as a keyword which is called when the constructor of the object is created. So self demo. Okay. So let's create this module. In this module, let's say I have a simple class self underscore demo, right? In this class, I create about the same demo. Okay. Then in this class, let's say this is will create a method. So and I'll say self comma name, right? Comma name. So here we say name equal to self dot name equal to name self dot self dot name equal to name equal to name. Right? This is done. I'll say def. I'll say just concat, right? Concat self, and I'll say full underscore name is equal to self dot name. We'll have a space in between and then say self dot name and say print and say full underscore name. Sorry, concat operation don't work here, so we have to add plus, right? So now this is our object is created, right? Now in this class is created. Now we'll create an object. So for calling any method, for creating object, we'll create our main method that is self main, which is should be having no parameters as of now. I will create an object. So the way we create an object in Python is just say obj equal to self underscore demo1, and in this, now here comes the beauty of init functionality. So whenever you create an object of the class in Python, we have init method which automatically getting called, which is act as a constructor in Python, and it pass these two parameters to these two variables. So when we create the object of the class, this init function, init method is getting called automatically. You do not need to do anything explicitly for this, right? So when I say name, I'll say swap, and then I say swap. Right. So this has been created. Now object is created. Once object is created, we can call the object. We can call the methods of it, right? And that's all is the method. What's the problem with this? Okay. And then we call the main method. And I want to execute all this. Let's see if it executes. See, it executes and it is showing swap and swap2. So if you see the execution, we have the class, we have the init method, we have our own function created here. So we created a main, which is our entry point to the code. We created the object. When you created the object, we are passing the two strings, swap and swap2. So when we pass this two string, this is getting automatically assigned to the self variable. Same is used across the class anywhere. So if you put, now if you just say, if you just put it here like this, self, and I say I write another function, just say display disp, okay, and then I say print just the maybe the self dot full name. So it's not the self.full name. I'm just trying to put display whatever is the displayed, whatever is the past, right? So when I run this, any method I didn't call it, sorry. So I have to call this function. So whenever I run this variable is also accessible throughout the class. So this is the beauty wherein we of the Python, wherein we create object. The variables are as constructor is automatically called. It assigns the variable, it initialize this, and then you can use your operations or your any sort of your operation on those variables, modify those variables, or maybe uh, store it in some HDFS files or anywhere when you are working with the Spark or other related languages which support the Python. So this is how the self keyword works. So after this, we'll learn what is stateful and stateless. So as the name suggests, like the state of the object, attributes, variables is only for the execution, just like process is executing for the first time. So this is suitable for functional programming. So like the variables, as it is saying, let's take an example to actually know how the stateless work. So if you see here, we had a pure function right written. So in this function, we're passing a list. The list element is passed here, and we're multiplying each element by 2 and returning a new list. So here, if you see, no variable has been modified and persisted, or not persisted, but not even the state is maintained, right? So till the life of this execution, till the life of this function, till the execution, this function executes, modified the new list, which is multiplied by 2, and returns the result. So state is not maintained. Like for the execution time, the only state is maintained. Once the execution is done, uh, the the state of the variable is released, or they are released from the memory for that matter. Within this function also state is not maintained. We are not talking about outside of this execution, but within this also we are not maintaining state. So this is an example of stateless behavior of the functional programming. And then again a stateful. The next point is a stateful. Here, as the name says, like we are maintaining the state while we are uh, executing the our class or anything or a function. So this is mostly suitable into OOPS programming. So before we learn the self thing, right, we are maintaining the state of the variable. So let's take a small example on this. So let's consider the OOPS example, which is stateful, right? So similar way we did before, it's the class operations. Okay, here we are doing operations like multiply, assign, or like uh, changes for change the function name for better understanding the things. Okay. So here is a class which is having the constructor, which is taking the self, as we discussed in the last example how the self work. Then this is a method which is just applying the multiplied by 2. Then again we are changing and saying multiplied by 2, uh, and then see the results, like how the result change. So and this is the main method. We are creating the object of this class, and we are calling the method. So now when I run this function, this class, sorry, I'll get the output as 16. So why 16? Because I'm passing a 4 here, right? 4 into 2 is 8 here, and here also it should be 8 because the variable y is 8. But here, if you say here 4 multiplied by 2 is equal to 8, and that 8 is again this 8 is carried out here, which is 8 multiplied by 2 equals to 16. So this is our answer, 16. So here the state of variable, which is 8, is maintained in this first function multiply, and in the second function change, although 8 is carried and the calculation is done. So this is where the state of the variable is maintained, or state of the object is maintained. Like for this object value is y of a, value of y is 8. For this object value is 16. So that's how it is, where we maintain the state. So with this, we have to decide like if we have both this functionality, when to use what. Like we have functional programming where we have the um, OOPS concept. So when to use what, that is the important question. But it is always a developer choice to use what programming concept or language concept he or she want to use. But the basic rule of thumb is, let's say, if you if your operations are, let's say, if you want to decide, let's say I want to use the object oriented approach, then you say, like, if you have a fixed set of operations on the things, then you should go for object oriented language. Like, consider a class which is having four operations, like tax calculation, then salary calculation, then accounting. So this set of operation, this class is for bank or maybe for the tax form. So these operation set of are fixed; they will never change, right? So this operation will never change. In this case, you'll go for class or object-oriented approach, because tomorrow, if operation changes, then we have to modify all other classes, then again inherit those classes, or maybe modify some methods. So that is not expected, because we have operations are fixed. We put those all operation in the class and implement this class, and put maybe we put some other inputs to the implement the same class, and we put some other input to the class so that same operations are executed on those data. And in contrary, the functional language is good when you have fixed set of things but not operations. Like here, operations are changing. Today you are saying, I need your bank, your tax firm has the accounting, your tax calculation, their salary calculation. But this is fixed thing for your bank. Mostly it's the fix. But tomorrow, if you are, let's say, talking about the, let's say, uh, a cricket dashboard, or like the dashboard which shows the cricket. So sometimes the statistics also fixed, but now we are coming with a different stat. So let's say tomorrow we want to display the functionality which says, like, I want to display the cricketers, let's say, highest score in last three matches, right? So they might include, like, they will say they might say, like, they want to display the highest score in the last four matches. Now you need to modify this functionality each time, right? You have to write a function to get the uh, maybe this is parameters wherein you can pass them on, but there are functionality wherein functionality changes frequently. So instead of going into that pain wherein build a class, write a method, inherit it, you just write a function, get your work done, call the function, and display the results. So that place the functional programmer will help when your operations are not fixed, but your things are fixed. But when your operations are fixed, then you should go for object-oriented approach. With this, we come to the end of this small video. I hope you like this video. Uh, for more course information, please log on to zealoustech.com. And thanks for listening. Have a good day.